This should be self-contained 100% just on the strategy pattern, unless you do not understand basic OOP concepts. If that's true, refer to part 1 and 2 of these tutorials. But from this point on, all of these tutorials will be 100% self-contained. And to teach you the strategy pattern, I'm going to write bad code so you can see in what situations you would need the strategy pattern. I'm also going to demonstrate it in code format, just like always. And then I'm also going to explain it using a presentation as well as a UML diagram. And like always, all of the code is heavily commented, and this is another great way to learn this concept. Download the code and read the comments. It's free, so why not? So let's get into it. Okay, so here I am over here. We have a couple classes defined. We have animal.java, and then we have two subclasses underneath of it, dog.java and bird.java. And what we're trying to try to do here is figure out how we can give bird.java and other animals that are subclasses of animal.java the capability to fly. Now this is where the bad code part comes in, because I'm going to come in here and just think about how we could accomplish this using techniques that we've already learned. Well, one thing I could do is just come in here and go public void fly and create a method inside of animal.java and then have it do something like I am flying. Print that out on the screen. And there you go. Well, why is this bad? Well, you never want to add any methods to a superclass like animal.java if they do not pertain to any subclasses. You need to separate what is different between subclasses and their superclass. But your answer to that might be like, oh, you're being silly, because inside of dog I can just simply come in here and override just like we've always done in the past and just create my own fly method and everything's going to be dandy. And you could do that, but again, we're learning rules here on how to write good code. We need to continue to abstract out what is different and put just those things that are different inside of the classes. Now, however, that would not make sense to come in there and just put it in the bird.java class, because in that situation, because we would be creating a lot of duplicate code if we expect a lot of our animals to be able to fly. So we would go in there and continuously, every time we created a new animal and it just so happened to fly, we would go in and add in the method fly over and over and over again. So we also want to avoid that issue. So let's go back over here and let's delete this because that's just wrong. Don't want that. And you're also going to find, if you would come in here and create an interface, let's say called flies, that would then force all animals to figure out exactly how they're going to use the fly method, that is also going to create a massive amount of duplicate code. Two basic principles that you really have to get into your head is you want to always eliminate duplicate code, and you also want to eliminate any techniques that cause one class to affect others. A superclass change shouldn't break code in a subclass, and vice versa. If there is a situation in which that seems to be happening, you definitely want to rectify that. However, using the strategy pattern, we are going to use an interface, but we're going to use it in a completely different way. In this situation, I'm going to create this interface, flies, just like we did before, except in this situation it's going to return a string. That's not really important, so don't really focus on that. What is important is we are going to create separate classes. It flies, which is going to implement the flies interface. And then in this situation, because it's going to implement that, we're going to go add on implemented methods and get rid of all this extra nonsense we don't need. And then in this situation, we're going to go into return, and I'm going to type something like flying high. And then I'm going to create another class, so I'm just going to copy this. And it is also going to implement the flies interface, except it's going to be called can't fly. Yes, I know that's spelled incorrectly. And then here we're just going to change this to return I can't fly. And there you go. So now what we did was we created an interface, and we're then going to use this interface inside of animal as an instance variable, and then we're going to dynamically change that instance variable to be either of type class it flies or class can't fly. And why this is a great idea is the interface is implemented by many other different subclasses, and what this is going to allow us to do is create many different types of flying without affecting animal or any of the subclasses. And then from that point on, classes that implement this new fly interface are going to allow those classes to use that code while also eliminating code duplication. And this is known, this is a technical term, as decoupling, which means that we are encapsulating the concept or the behavior that varies. And that behavior or concept is the capability to fly. If you're not quite getting everything, don't worry about it. I'm going to show it to you in multiple different ways. So let's jump over into animal and implement this. And it's going to be quite easy to implement. Remember, we're just going to create a new instance variable. I'm going to make it public. I'm going to call it flies, and it's going to be of type flies, and I'm just going to go flying type, like that. So instead of using an interface in a traditional way, we use instance variable that is a subclass of the flies interface. An animal doesn't care what flying type does, it just knows the behavior is available to all of its subclasses. And this is also known as composition. Instead of inheriting an ability through inheritance, the class is composed with objects with the right ability built in. And another great thing about composition is it allows you to change the capabilities of objects at runtime. So if you create an object, an animal object, and it starts off as a non-flying object, but then it grows a set of wings and all of a sudden can fly, dynamically you can go in and say, okay, I know this object didn't fly before, but now it does. So it gives you a never-ending supply of different capabilities. So now that we've created this guy, we're going to be able to just zoom down inside of animal.java and type in public string try to fly, right like this. And then it's going to return flying type, and it's going to call the fly method, right like that. And then another thing, if we're going to make this all dynamic, which of course we want to if possible, we're going to go public void set flying ability, and it's going to be passed a flies object, which is going to be new fly type, and then we can set flying type dynamically, new fly type, by setting it to that object. So let's save that. So now what are we going to have to do with dog.java and bird.java to make those work? Actually, very little. We're just going to go into the constructor area whenever our dog object is built, and we're going to say flying type is equal to new, and in this situation we're going to call can't fly. This is going to set the fly interface polymorphically, and this is also of course going to set it as a non-flying animal, and by polymorphically of course I just mean we're going to refer to the flies interface, but we're going to set it to use can't fly, the can't fly class underneath of interface. So that's it. That's all we need to do with dog to give it the capability to not fly. And you might say to yourself, well, the bird must be really hard to get it to fly, of course. Nope, I'm just going to go in and go flying. Type is equal to new, it flies. So we're using polymorphism, we're doing all kinds of crazy stuff, and that's it. You're done. So now let me try this tricked out program. Let's just file save that, and we're going to jump into animalplay.java. We're just going to create some things. So I'm going to create an animal called Sparky, and he's going to be a dog. And then I'm going to create another animal called Tweety, and she's going to be a bird. And then go system out, print line, and let's say we go dog, and then have Sparky figure out if he can fly or not, and see what it's printed out on the screen. And then we're going to do the same exact thing with Tweety, but we're just going to say bird here, Tweety. File save it, execute it, see what happens. And there you can say, dog, I can't fly, bird, flying high, just the way we want it. And then I'm going to come over here, remember animal.java, I created this method here that's going to allow me to dynamically set my flying ability. Let's say our dog here all of a sudden gets this amazing ability to fly, flying ability. I'm just going to create a new object inside of the dog object by going in and setting the instance variable for animal.java. So all I'm doing is passing it a new one of these flying types inside of here. And to do so, just go it flies. Just create it. File save. And now after doing that, boom, file save, proceed. And there you see, now the dog flies. So that's the code for it. Now I'm going to jump over and show you a UML diagram to sort of make sure that I completely cement this in your head. Okay, so here is our UML diagram. Basically, we have our animal, and the plus here means that this is a public instance variable or a field, and its name is flying type, and it is of type flies, and flies is the interface over here. And the actual strategy involved in the strategy pattern is to define a family of algorithms. These are the algorithms: it flies or it can't fly. There they are, just those two. Encapsulate each one and make them interchangeable. So we're going to encapsulate them inside of this interface called flies, and then we're going to allow the animal over here, as well as all of its subclasses, to dynamically dynamically switch between either you being a it flies or a can't fly. What's great about the strategy pattern is it lets the algorithm vary independently from clients that use it. So it's really cool. All this different stuff is all inside of there. So let's review. You are going to use the strategy pattern when you want to define a class that will have one behavior that is similar to all of the other behaviors in a list. So we have animals that fly and animals that don't fly. The similarity is that flying is involved, whether it is they can't fly or they can fly. Or, to explain it in another way, you want a class object to be able to choose from, not flying, fly with wings, fly super fast. By adding in the strategy pattern, you're going to be able to dynamically create whole new different types of flying typed animals. So to get right down to it, you're going to use the strategy pattern when you need to use one of several behaviors dynamically. Other good reasons to use the strategy pattern: it often reduces long lists of conditionals. So if you start seeing that you're using many different types of conditionals, chances are strategy pattern is going to help you out. Of course, like we said 100 times, it avoids duplicate code. It keeps class changes from forcing other class changes. It also allows you to hide complicated or secret code from the user. And pretty much there is only one negative: you're going to have an increased number of objects and classes if you use the strategy pattern. So there is the strategy pattern. Leave any questions or comments below. Chances are, though, the code is going to explain it all to you. So go and get it. Otherwise, till next time.